Yes, you're welcome to our lesson 4 of colligative properties. Remember, in lesson 3, we had started looking at some examples. We looked at how we could use colligative properties to calculate the relative molecular mass of a non-volatile solute. And specifically, we are looking at the depression of freezing point. So now, after looking at example 1, it is fitting for us to look at example Example 2. And I left a question for you, and I said that I will come back and we do it together. So here we have example 2, and it was saying that the cryoscopic constant of benzene is 5.12 degrees Celsius per mole per kilogram. Explain the meaning of that statement. This question is someone indirectly telling you, do you know what a cryoscopic constant means? By definition, we say the cryoscopic constant is depression in freezing point, which occurs when 1 mole of a non-volatile solute is dissolved in 1,000 grams of a pure solvent. So now, if that is the definition of colligative property, a definition of cryoscopic constant, can we apply that to this statement here? They have now given us the cryoscopic constant as being 512 degrees Celsius per mole. So can we give a solution to the answer? To the question now. So what does the statement mean? So 5.12 is a depression in freezing point. Okay? So we can say that 5.12 degrees Celsius is the depression. In freezing point. The depression in freezing point that occurs when 1 mole of any non-volatile solute, when 1 mole of any non-volatile solute is dissolved in 1,000 grams. 1,000 grams is 1 kilogram of 1,000 grams or 1 kilogram of benzene. Benzene is our solvent. This question is trying to test you whether you can apply the definition of cryoscopic constant. Can you really know what it means? Can you apply it? So here I'm trying to apply it. The cryoscopic constant of benzene is that one. It means that is the depression in freezing point that occurs when I get any form of a non-volatile solute and I dissolve it in 1,000 grams or 1 kilogram of benzene. I hope that is clear. Let's go to part B. Part B, solution of part B. Now, in part B, they are saying a solution containing 0.142 grams of naphthalene in 20 grams of benzene. Now, when you look at a question, you should be able, even when you do not know the compounds, you should be able to know which one is the solute, which one is the solvent. Normally, the mass of the solvent is far bigger you can see the mass of benzene, 20 grams. And the mass of the solute is smaller. Remember, one of the limitations of colligative properties, we said that the solution should be dilute. For a solution to be dilute, then the solute added should be very little and the solvent should be big. So in all the questions that we shall be looking at, you will actually be seeing that the solute is very small, the solvent is bigger. So that means naphthalene is our non-volatile solute. 20 grams of benzene, benzene is our solvent. That is even why the chromoscopic constant given was for benzene. So it caused a lowering of that. Now in this question, you need to understand what is 0.284 degrees Celsius. Remember, the colligative property is the depression, dP. dP is change in freezing point of the solvent minus freezing point of the solution. In our question, they are not giving us the freezing point of the pure solvent. Like in the first question in lesson 3, we had the freezing point of water. Here, they are not giving us the freezing point of benzene, but they are talking about a lowering of the freezing point of. This preposition of tries to tell you that this is the depression in freezing point. So in our solution, we shall say that dP dt, depression in freezing point, is 0.284 degrees Celsius. Okay? Then they have given us the mass of the solute, which is 0.142 grams. They have also given us the mass of the solvent, which is 20 grams. Then we also know the Kf from part A is 5.12 degrees Celsius per mole per Kelvin. So what we need is molecular mass of the non-volatile solute. What is it? So what did we say? Because our constant is in per mole per kilogram, it is very important that we change our mass of the solute into 1,000 grams of the solvent. Yes, this mass was dissolved in this. So we want to find out what would be the mass of the solute if it was dissolved in 1,000 grams. Why do we change to 1,000 grams? Because we can only relate to Kf if the units of the solvent are similar, if all the solvent is in 1 kilogram. So in our calculation, we shall first convert the mass of the solute to 1,000 of the solvent by saying that 20 grams of benzene dissolve 0.142 grams of naphthalene. Now the question is, what about 1,000? It is the solvent that we take to 1,000 because Kf is in 1,000 of the solvent. So we say, what about 1,000 grams of benzene? 1,000 grams of benzene will dissolve what? Will dissolve, so you get 1,000 times 0.142 divided by 20. So you will get 0.142 times 1,000 divided by 20 grams. And we get our answer. Let's get our calculator and find out. So we have 0.142 times 1000 divided by 20. We get 7.1 grams. So in 1000, we would have 7.1 grams of naphthalene. And after converting the mass that fits in 1000 grams, then we are right to compare the depressions. We are right to compare the depressions because we know how much depression was caused by naphthalene in 20 grams of the solvent. So we would now want to find out what would be the mass that will be caused by 1 mole of naphthalene. Remember, 1 mole of naphthalene will weigh a mass equal to its molecular mass. So what we are going to do now is to say that the dt here, this one caused by naphthalene is, we shall say, 0.284 degrees Celsius is depression in freezing point, is depression caused by 7.1 grams of naphthalene in 1000 grams of benzene. Then the question is, what about this? Remember, this will be caused by 1 mole, and 1 mole is molecular mass. So I will say 5.12 degrees Celsius is depression caused by 1 mole of naphthalene. And 1 mole of naphthalene weighs a mass equal to molecular mass. It's depression caused by molecular mass. So how shall we get that molecular mass? Of course, by cross multiplying this and this over this. So you'll get 7.1 times 5.12 over 0.284. So you get your calculator and compute. So you will have 7.1 times 5.12 divide by 0.284. So we get 135. I hope that is what we are getting. 135. We can try to repeat and see. This is 284. This is 7.1 times 5.12 divided by 0.284. Oh, see, I had pressed something wrong, so we get 128, and this is our molecular mass. Can be in grams if they are simply saying molecular mass, but if they say relative molecular mass, you may ignore the units. So this is our molecular mass that we are obtaining. Now, what is unique with this question? That this question was simply giving us dt. So you need to read the question and understand the language of the question. Some question you're given temperature, sometimes you're not. I want to give you one more example. Example 3. On example 3. Now in example 3, we are having calculate the freezing point of a solution. Calculate the freezing point of a solution, calculate the freezing point of a solution containing 4.2 grams, containing 4.2 grams of ethane 1,2-diol, of ethane 1,2-diol, ethane 1,2-diol. In brackets, we can give this formula. Ethane 1,2-diol in 30 grams of water. In 30 grams of water. In 30 grams of water. Open brackets, Kf of water. Kf of water is 18.6 degrees Celsius per mole per 100 grams. So there are quite many unique things about this question, but still we can try it and solve them and see. Let's look at the solution here. So in the solution, there are quite a few things that we need to analyze. They are asking for freezing point. Where do we get the freezing point? Remember that dt is freezing point of the solvent, subtract freezing point of the solution. So that means if I know the freezing point of the solvent, what is our solvent in the question? The solvent in the question is water. So what is the freezing point of water? 0. So our dt would be 0 minus t. So you realize that we do not have the freezing point of the solution. So if we don't have the freezing point of the solution, it means that our calculation should target on getting dt. If we get dt, then we shall make the freezing point of the solution the subject. And if we make the freezing point of the subject the solution, then we shall be able to get the answer that was asked. So our target is dt. Now, the other unique thing about the question, is that they have given us the name of a compound and the formula of the compound. So the formula of the compound is actually to be used to get the molecular mass of the non-volatile solute, because our solute is actually this compound, ethane 1,2-diol. So you can calculate the molecular mass of the compound. Molecular mass here will be calculated by adding up the atomic masses. And so hydrogen is 1. How many are they? This is 1 times plus 2, those are 3, plus 2, those are 5, plus 1, those are 6. So the atomic number of each is 1 times 6 of them, plus oxygen, it is 16. How many are they? 1, 2. So these are 2. Carbon atoms are 2. Each of them is 12, but there are only 2. So what is the molecular mass? The molecular mass is 6 plus, this is 32 plus 24. The answer is 64. I mean 62. The answer is 62. So now we shall be seeing that we have been given the molecular mass indirectly. And so what is the other part of the question that is unique? The other part of the question is about Kf. Kf is normally given per kilogram, but this one has been given per 100 grams of the solvent. So what we shall do, instead of converting our mass of the solute to 1,000, we shall convert it to 100, so that we have same units of kf. Okay, so let's see, what are we going to do now? So we shall now say that 30 grams of water, 30 grams of water dissolve 4.2 grams of HOCH2CH2OH. Okay, then the question is, what about 100? This time not 1,000. What about 100 grams of water? Will dissolve. So you have 4.2 times 100 over 30. Why I'm using 100? Because Kf has been given in 100, not per kilogram. So I have 4.2 times 100 divided by 30. And this is 14 grams. So after getting this, I can now go ahead and relate the dt. Remember, I want dt to be able to calculate the freezing point. So what am I going to say? I now have this. This is, I now have this, the molecular mass of the non-volatile solute. This was for the other question. So now I would say now 62 grams. This is molecular mass, 1 mole, so should be related to this. So I say 62 grams of solute cause dt equal to 18.6 degrees. What about 14 grams of the solute? 14 grams of solute will cause 18.6 times 14 divided by 62. Okay. So now when we come for lesson 5, we shall be completing our calculation and then see how we proceed to get the freezing point of this non-volatile solute. Let's meet in lesson 5.